Recording. All right. Practice test day, which means, of course, in case you missed it, test number 1 is on Wednesday. You'll have all class to do it. It's not a 2-hour test, but I just want to make sure that you have enough time to do it so you don't feel stressed out. Okay. So as promised today, we're going to work through the practice test, just kind of start to finish. I'll highlight things, right? Little reminders, little clues, right? And so before I forget though, on Wednesday for the test, because whether it looks like it now or not, we actually have a full class, okay? And so I'll be doing assigned seating, okay? And so each test will have a name on it. You have to find your name and write that test, of course, which means you might not be in your usual spot, okay? And so I apologize. I know that can be kind of, but just now you know, you might not be in your same spot, or you probably won't be in your same spot, so you can prepare for that. It could be anywhere in here, but the air is all the same, so you're okay. All right, so just be prepared for assigned seating. Okay? That's because I don't know your names too, so it's kind of a cheater way for me to learn some names. Right? Oh, I see, okay, good. So on the practice test, I don't think there was anything else that I was gonna say. I don't think so. I'll remember later, maybe. I don't think, no. I've made a list of the core concepts, just as a quick guide of what we covered in each section, right? What are some things that I could test you on, right? And so here I've jotted down roughly how many marks to expect for each section. The only one that I'm really sure of is this 8 marks for linear programming, because it's just one question. And so I should have added them all up, but I feel like roughly 22 marks for chapter 1, which was things like, what's the slope of a line? Can you build a line, right? Can you draw a line, right? All those skills. Can you solve a system, right? Can you solve for the intersection of 2 lines, right? And so 22 marks, that's a pretty good chunk, right? If you're feeling good about lines, then that's a good amount of your grade, right? Linear programming. In my announcement, I said, okay, just so you're aware, there are 2 optimization problems on the practice test, but on the test, there's only 1, right? And so you don't know if it's a maximization problem or a minimization problem, right? You need to be ready for both, and so I wanted to give you practice for both of those. Okay? So we'll do those today. And then we have logic. Logic is roughly 11, or I want to say 10 marks, but let's say 11 just because that's what I have written down here. And so that last section on logic, right? Conjunction, disjunction, we call them and or, right? Fancy names. Truth tables, right? And conditional statements are kind of at the heart of all these for logic. For a total of, I'm not committing to anything, roughly 41. I can't remember if it's 40 or 41. I like to have out of a nice number. 41 is not a nice number, but oh well. Any questions about that distribution, it becomes roughly how much time we spent on each topic. So it's kind of proportional in that way. Then on to our practice test. So like I said, I want to start at the beginning and then work our way through in order. Okay. And what I want to do, because it's a question that I often get, okay, how much work do I need to show? You have to show a lot of work, right? Show me, it's your job to show me how much you know, right? So always show me as much as you can, okay? And so what I'll really try to do is anything in dark blue, you have to do for full marks, okay? So you have to show that work. It's not optional. You have to show it if you want full marks, okay? Sometimes I'll add in extra work to show where I got stuff from, right? And so I'm going to try to do that in light blue. And just so you can kind of, okay, that I don't need to show. If you're comfortable skipping that step and going next to the next step, that's okay. And sometimes it's just kind of, where did I get this thing from? Right, so extra notes. Okay, we start off nice and breezy. We have a line 3x minus y is equal to 12. If we have to complete the following ordered pairs, right? What's some things we need to remember? Well, an ordered pair looks like this, x, y, right? So part A says that if we let x be 2, we need to solve for y. Right? Let x be 2 in 3x minus y is equal to 12. So then I have 3 times 2 minus y is equal to 12, which makes 6 minus y is equal to 12. I guess now I'm gonna be picky. I want to see this. 12 minus 6 is 6. Negative y is 6, which means y must be negative 6. In terms of the ordered pairs, but I'm not actually going to be looking for it, it would be 2, negative 6. As soon as I see that y equals negative 6, I move on. Right? You don't have to write it out properly. But it's nice. In the next one, it's saying that y is going to be 6, and we're going to solve for x. So we're going to let y be 6, which is different from what we found earlier, right? We found y is negative 6. All right, so just be careful. So y is 6 in 3x minus y is equal to 12. So 3x, oops, 3x, not 6, minus 6 is 12. We get 3x. Should I show? I'll do the step in blue. 3x, I should have done it earlier, I guess, is 12 plus 6, which means that 3x is 18. Oh, 18 divided by 3, is it anything nice? Six. Still nice. I was sold. then we have 6, 6. How can you check these? In the original equation, if you put in x is 6 and y is 6, the answer should make 12, right? And so all of these ordered pairs, you should be able to plug them into the original equation and you should get to 12, right? Otherwise, you've done something wrong. So that's nice. You're always able to check your work. And what about this last one? Y is 0. Let y be 0 and 3x minus y is equal to 12. If y is 0, right, what do we know about y is 0? This must be the x-intercept, right, that we're finding. That's more useful later, right, when we have to graph lines. 3x minus 0 is equal to 12. So 3x is 12, so x must be 4. So we have 4, 0. And this is the x-intercept. Nice. And oh, and I should point out, the numbers in the box are the number of marks. And so each of these, 1 mark, 1 mark, 1 mark, right, in the bag. We're already at 3 out of 41. Feeling good, right? How about another 2 marks? We have to find the slope of the line passing through the following pair of points. We have to do it twice, but that's okay. We won't be mad. How do we find the slope? Well, it's on your formula sheet. Yeah. Beautiful. Nice. Which, of course, is on your formula sheet. Although what I'm tempted to do, so I still have to print them. I know. Bad, Emily. I just do it late at night. No one's here. Because we don't have very many formulas for this test, I might just put them on the front page. Is that okay with everyone? I just put them on the front page. Save a little bit of paper. Also, I might clean up the rest of the formula sheet so then I don't have to toss those. So this will be on your formula sheet / the front of the test, but you can detach if you want. A lot of these you'll know anyways, like this one. So the slope we have to find. All right. Doesn't matter which one you use as 0.1 and 0.2, right? I'll just use the first one as 0.1, second one as 0.2, because I like doing that. But it means I have to read them backwards, which is not always easy. 9 minus 3 over 5 minus 2. And ideally, I want to see this formula. Don't have to for full marks, but it'd be nice if you started with the empty formula. That's a nice way to show what you're thinking about too. Bless you. 9 minus 3 is 6 over 3. I'm going to go for 2. That's all we had to do, find the slope. Yeah.
I have a feeling if we do write things that like you say considered or not needed, but we still write them anyways, or like show everything, you're not gonna take it. Right?
No, no. I encourage you to write down everything that you know. Okay? So even if you come across a problem and you're completely stumped, I get it. It's a test and you're nervous and it's our first test and you don't know what my tests are like and maybe you're just I know how to solve this. If I could just get this thing, right? If I could just find the slope. Okay. What I want you to do then is say, I forget how to find the slope. This is an example. I forget how to find the slope. Write that to me. So I will use a slope of 3, right? And then just keep going. Right? Can't give you marks for the slope because you didn't do it, but you were able to carry on and show me that you knew what to do. Right? So just my most important thing is that you show me that you know what you're doing. I don't care about the answer, right? Little calculator errors. Yeah. It's nice when I see some work and I see the final answer and it's good. That makes my job easier, right? But if I see a wrong answer, I'll go back and see, okay, what happened, right? Is this a big mistake? Is it a little mistake, right? Little mistakes, I just take off half a mark, right? Or if it's really, really minor, no marks off, but usually half a mark. Yeah. So show me everything, tell me everything you know. Okay. Next one. I'll do it like how I would like to see it. This. Y2 is 3 minus 1 over, whoops, 1 minus -1, sneaky. 2 divided by 1 minus -1 is +1, so that's 2. So I get a slope of 1. Nice. I wonder what the next one will be. Probably a line of some sort. Let's see. Oh, another gentle one. Wow, I'm nice. The first one, I'm really nice. The second one, not as nice. Why do I say that? It's easy to see what the slope is if it's in the form y equals mx plus b, right? Which the first one is, the second one isn't. So we have to rearrange a little bit, but we can do it. Okay. In this is all I'm looking for. The slope is -2 since y equals mx plus b. So I'll just explain where I got that from. But all I'm looking for there, for 1 mark, slope is -2. From 2x minus y equals 6, I have to solve this for y in order to easily see it. Or, what's your other option? Ooh, dig deep. Yeah. You can rearrange it, solve for y. Or, because it's in standard form, the slope is -a over b, but that's not on your formula sheet, so you'd have to remember that. And I think just rearranging it is easier, right? And so here, recall the slope is negative a over b, or, which means it would be negative 2 over negative 1, which is 2. But let's rearrange it. Negative y is 6 minus 2x. So y is negative 6 plus 2x. Therefore, m is 2.
I will write 2x plus
2x minus 6 would be correct. But you have to distribute this negative onto both of the terms. Because technically what happened here, I'll do a y equals negative 6 minus 2x in brackets, and then you have to put it on the 6 and the 2. But you could do 2x minus 6 and it would still be true. Yeah. Same answer is good. Then you're good. As long as you get to the right answer. I didn't think about yeah, you could build a table, right? Totally. I just always just cling to y equals mx plus b, because it's just easier for me. Or if you recognize the standard form and you have it memorized, not really worth it. You don't get extra points, but it would make it quicker. Mere moments quicker, but still. Okay. Look at us go. How many marks is that already? 5, 6, 7. Just collecting marks. Okay. Now, I have a feeling that these, I'm pretty sure I changed these to 2 marks each. You'll see why. For A, we're given a point and we're given a slope. So you might recall the point slope form of a line. Now, the benefit of me putting the formulas on the front page is because for this test, I can give you the point slope form of a line. On the final exam, though, you won't have it, but I also won't expect you to need it, right? If you need it, I'll give it to you. But recall, we have y minus y1 is m times x minus x1 is another way that you could construct a line. Right? Should we do it without it, though? Without any special tricks? Let's just go brute force. Right? So you could use this, right? What's your x1? It'd be 3. What's your y1? It would be 10. What's your m? It'd be 2. Right? Rearrange, because it asks for it in the form of y equals mx plus b. But, so it's only slightly easier. Okay. In the form y equals mx plus b, I'm given the slope of 2. So we can start there. And I have a point, which means I have an xy coordinate, which lets me solve for b. And so what I can do is, when y is 10, x is 3 plus b. So I get 10 is 6 plus b. Which means that b is 10 minus 6. 4. This, I guess this one was kind of a 1 marker. Oh well. I'll keep it 1. It wasn't that much work. It's like the same as before. So therefore, y must be m, which is 2x plus 4. I'll say or, recall. Either way, you're doing the same thing, right? Rearranging and solving for b. The next one I will keep as 2 marks. Why? Because first you have to find the slope and then you have to find the intercept, and that's 2 separate things. Right? So step 1, find the slope. That's just a note for you. M is y2 minus y1 over x2 minus x1. I find I usually have all my formulas memorized, whether I want to or not. They just sink in. -1 minus 5 over 2 minus 3. I get a slope of -6 over -1. So I get a slope of 6. Now, I'm in the same spot that I was in part A. Right? I have a slope, and in fact, I have 2 points. I just have to pick one that I like, it doesn't matter which one, and solve for B. So step 2, solve for B. In y equals, oh, this is also light blue. Okay, that doesn't look like a B. There. What's one? I'll use the first point. I always do. Yeah.
Does it matter if you use like 3,5 with the xy as corner 2? Because I did the opposite, but I went to
Yeah. No, it doesn't matter. Yeah. In fact, the kind of clever way to do it is to use this as 0.2 and this as 0.1, because then you don't have to read them backwards, which I have to be really careful about. And so that's the clever way to do it, but I want to show you that it doesn't matter as well. Okay, so I'll use the first point to solve for B, which means that y is 5, the slope is 6, and x is 3. 3, 5, yeah. 5 is 18 plus b. Get a b of -13? Question mark. Therefore, y equals 6x minus 13. Oops, clean up that 3. Which you would find -13 if you use the other point as well, so it doesn't matter. There, that's 2 marks. 1 mark, 2 marks. Step 1, step 2. I knew there were some that I needed to bump up the grades on here. Maybe I'll just do it on a new page here. Start fresh. Now, we have to write an equation of the line satisfying the given conditions. That's the same as before, but you have to write the equation in standard form, right? AX plus BY is equal to C. Okay. So slightly different, same idea. Where do I like to start? You've got a couple of options, but I like to just follow the same procedure that we were using earlier, right? Find the slope. Sometimes we know the slope, which is the case in the first one, right? And then find B and then rearrange, right, into AX plus BY equals C. Right? Might be the easiest thing to do. But this one's tricky because I can think of a couple of different approaches that you could take. So as long as you end up in the same standard form in the end, you did it. That's great. And if you're unsure if what you did makes sense, then I can have a look after class. Okay. In y equals mx plus b, I have when y is -1 and m is 2 and x is 3, I can solve for b. So I get -1 is 6 plus b, which means b must be -7. -1 minus 6. Which means, so y equals, the slope is 2x minus 7. But in standard form, right, what do we have to do? We have to get our x's and our y's to the left in that order, right? X and then y, and then leave that -7 on its own. So I get -2x plus y is equal to -7. I'll highlight here, just making a note. In standard form, we must write ax plus by is equal to c, and I'm just going to highlight the x and the y order. It's in the question, so it's not something that you have to memorize, but you do have to remember to do it, right? Because it would be tempting to write this as y minus 2x, and that's not wrong. You just didn't follow instructions, which I don't like. I want you to follow instructions. In my undergrad, he later became my supervisor for my master's, but he would start class and he would just list all these facts that we had to remember for the entire class. He would say, okay, today the sky is green and 2 plus 2 is 13, and just give a list of wrong things, and we had to remember them all. And then he would ask kind of throughout the class what these things were. And so 2 plus 2 is 13. Just remembering. So you have to follow instructions. Okay. And we did. We learned that you just remember to do all the things. But aren't you glad I don't make you do that? Or maybe it would be fun. I don't know. Maybe I do make you do that, but it's math. Haha. Now we have 2 points. This one should be 2 points as well. Because why? Well, you have to find the slope, and then you have to find the intercept. I'm not even giving you any extra marks for rearranging into the standard form. It's just following instructions. That would be nice of me, but I'm not going to do that. Oops. Okay. Step 1. Find the slope. Two minus y1 is over x2 minus x1. What were those points? 1 minus -3. 5 minus 2. 1 plus 3 is 4 over 3. Oh, rude. Rude. Fractions. We can do it. Stay strong. There's a trick, right? You don't have to work with the fractions. So let's see. Don't let it ruffle your feathers. Just keep going through the steps. Now you have to solve for b. So I'll use the first point, 2, -3, although 5, 1 looks a lot nicer, but I'll use 2, -3. So in y equals mx plus b, -3 is 4 over 3 times, keep forgetting, 2 plus b. Let's see here. I'm going to simplify. 4 times 2 is 8 divided by 3 plus b. Oh. What can we do? You can multiply. I think you were going to say it. I know. You guys are being so good answering all my hypothetical questions. I'm used to just answering my own questions. Just right away. What can we do? We can multiply. As long as we multiply both sides of the equal sign by 3, that's allowed. I'm not changing anything, right? So let's do that. 3 times -3 is 3 times 8 over 3 plus b. Hopefully you can see why I chose 3, right? Because it's the troublemaker in the denominator that I want to magically dissolve, right? And so that's why I chose 3. Oops. Oh, there. Making sure you do it to both sides, right? And especially this right-hand side, you have to multiply by 3 on both of these terms, right? That's probably because at this point, you're just trying to solve for b, and you might forget this step, right? And so you get -9 is 3 times 8 over 3. Okay, find this part plus 3b. This part I'll do in light blue. You don't have to show this step. You just jump straight to the cancellation, that's okay. 3 divided by 3 makes 1. 1 times 8 is 8. Right? And that's the reason we did it. -9 is 8 plus 3b. We're almost there. -9 minus 8. I better bust out my calculator. Big numbers here. And thank you. -9 minus 8 is indeed -17. But 3b is -17, which is a real reason. 17 divided by 3, is it anything nice? It's not. So I'll just leave it as -17 divided by 3, another fraction. That's okay. Oops. I'll add a step, step 3. Rearrange into standard form. Rearrange into standard form. The other one was easier, I think. Here we're going to need to do a little bit more work. Yeah. Because it's a repeating decimal, as long as you keep all your decimals in your calculator, that would be okay. But you don't want to do any rounding. Does that make sense? So if you're able to carry all your decimal places, because otherwise you're going to lose a nice clean number at the end. So it's, but if you can carry all your decimal places, go for it.
Follow on with your question. My calculator has a recall score button.
Go
If
for it.
I put on the test like STOA.
Yeah.
Which is what my calculator says. Would that be okay with you? Like I'll write out numbers.
Oh yeah. Yeah, so usually how I do it is I just kind of highlight here that this is stored in A. Right. And then you can use RCL. RCL.
Yeah, wanted to say hi.
So yeah, you can use the store function. Yeah. So a lot of calculators have a store and a recall function. If you here, do this. Do I have one handy? No. Let's do this. This is where it gets a little bit weird. I'll take a picture of my calculator and bring it up. How about them apples? So a lot of calculators have something that looks like this. So you might have an STO button or an RCL button. Yeah, is it the RCL and then the store is in the second? So yeah, so I have an old calculator. I think they went maybe the other direction, but they do the same thing. And so what you can do is if you have kind of a weird number like 5/3, for example, doesn't make anything nice, then what you can do is as long as it's on the screen here, then you hit store, okay? And depending on your calculator, if you have one of those financial calculators, you can store it in the numbers. So you might have to look up how you can store things. But on this calculator, you store it in either A, B, C, D, E, or F. Which is why I like to make a note to myself where I stored stuff. Because if I'm storing a lot of things, I then need to know where to go back to it. And then what you can do is you can, to get to the recall, you would go Shift and then hit the same button and tell it which number you want to recall, right? And it'll bring it back up. Right? So it's kind of like a parking lot for big numbers. And I use that a lot. We haven't used it in this course, but we will. And so maybe I'll just kind of crop this up here. And I'm happy to have a look at your calculator, see if we can get it sorted if you want to. Once we get into kind of lengthier calculations, then I'll reintroduce the store button. But it's a really useful tool. Okay. Back to here. Y equals, we solved for M was 4/3. X, and then B was -17/3. Oops, it's a weird 3. Still weird. There. We can use the same trick again, right? I've got a troublemaker 3 here and a troublemaker 3 here. That's nice, because as long as I multiply both sides by 3, then I can cancel these 3's in the bottom. Right? So, did I do, yeah. 3 times y is 3 times all of this, 4/3x minus 17/3. An optional step, 3y is 3 times 4/3x minus 3 times 17/3. To show that those all cancel. This one's feeling like it should be 3 marks. Wow, aren't you lucky? 3y is 4x minus 17. Has to be in standard form. So I'm going to move that 4x to the left-hand side. So I get -4x plus 3y is -17. Right, making sure your x comes first and then your y. What do you think? Should it be 3 marks? I did do 3 steps. Okay. How about 3 marks? So it's approximate. Let's still change it. 1 mark, that's crazy. No. 2 or 3. 3 might be nice. You know how to do it. It's just that 1 extra step. Okay. Word problems. Everyone's favorite thing. Your formula sheet. Right? We've got the variable costs and the fixed costs, which really is just a line, right? MX plus B. So the variable cost to manufacture an item is $20 per item. And it costs a total of $750 to produce 20 items. If X represents the number of items manufactured and Y is the cost, write the cost function. Now I'll go back to the formula sheet and maybe I'll snag this guy here. So from your formula sheet, okay, I'll make it a little bit bigger. The cost function is C, which is the variable cost plus the fixed cost. The variable cost, we're told, is $20 per item. And X is the number of items. Right? So that means that the variable cost is 20X. That's your variable cost. Plus your B, which is your fixed cost. We don't have that yet. But we do have a cost for producing 20 items, which is when X is 20. And so here we know C, the cost is 750 when X is 20. Which is the same as an XY coordinate of 20 and 750. A little bit harder because it's a word problem, right? Kind of figuring out what you're given. But we really just want to solve for B again, right? We have a point, we have the slope. So now we can say that the cost is 20, oops, I forgot to replace the cost with 750 when X is 20. And I'll just call this F. I get an F of 350, right? Yeah. Therefore, the cost is 20X plus $350. Nice. Any questions about that one? I think the trickiest part about this one is recognizing that when it costs a total of $750, that includes your variable costs as well, right? And so you don't want to use that as your fixed cost. You have to solve for your fixed cost. But once you've seen that, then you can do it.
I guess anytime prices like refer to
Yes. The $20 per item. Is that the one you mean? Yeah. Yeah. That's always going to be the variable.
If I put B into the back. Right?
No, that's fine. Yeah. In fact, because I have it as y equals mx plus b, you could just keep it as y equals mx plus b if you wanted to. I'm just trying to match what's on the formula sheet. That work is not harder than the 1-mark question that we did before, right? Where you were given the slope and you had a point and you had to solve for b, right? But it's 2 marks because you have to pull that information out of the question, right? And that's hard. Huh? That was question 6. How about question 7? How am I doing for time here? Oof, time flies when you're having fun. I know it doesn't feel like it to you. I gotta get to those optimization problems, right? So a person who weighs 150 pounds has 60 pounds of muscles, and a person that weighs 180 pounds has 72 pounds of muscles. We're told that if X represents the body weight and Y is the muscle weight, we're going to write an equation describing their relationship. And then use this relationship to determine the muscle weight of a person that weighs 170 pounds. So I'll just jot down that X is the body weight and Y is the muscle weight. And we're given, in that case, right, 150 and 60 is the first point. And 180 and 72. That's the hard part. Pulling that information out, and we want to write this equation. I'll do the steps again. Step 1, solve for m. At 2 points. Get to work. Y, where m is y2 minus y1 over x2 minus x1. 72 minus 60 over 180 minus 150. 72 minus 60 is 12. 180 minus 150 is 30. I don't think that's going to be anything nice. It is. If it is, this is optional, but you might want to do it. So I just use my calculator. 12 over 30 is something nice. It's just 0.4. So you can keep going with the fraction, but I'll use 0.4 because it's a little bit nicer to look at. But if you use the fraction, you might want to use that multiply by 30 trick, right? Dissolve the denominator. But if you use 0.4, that's good too. Step 2, solve for b. Y equals 0.4x plus b. Oh, I guess I should use one of the points. Use the first one. 60 is 0.4 times 150 plus B. Okay, 60 is 60 plus B, which means B must be 0. All that work? Oh, it's nicer to work with. All right. There was an additional ask. So we can make this this line, right? Y equals mx plus b. And then we're going to use this relationship to determine the muscle weight of a person who weighs 170 pounds. So when x is 170. So now I'll call it step 3. Don't have to. Let x be 170. So y is 0.4x plus 0. You can drop the 0. Fine, I'll make it. Because I'm trying to stick to my color-coded. Trying. No guarantees. Uh, 0.4 times 170. 68 pounds of muscle mass or weight. Once I see that 68, I'll be happy. Move on. Huh? I would make this 3 marks, but in a scenario like this where I give you 2 points, right, that are on the line, and I ask you to make the line, and then there's a follow-up where you use the line, I'm gonna say about half of you will forget to use the line. So I don't want to make that its own mark, because then you'll lose all those marks. Usually I try to make it so that your marks are as high as I can make them. I know where you're gonna get there and forget about that last part. So I'm gonna keep it at 2 marks. But I'll be really happy when you get it. How about that? Two linear equations. Solve for x and y. It doesn't say use the elimination method. It doesn't say use substitution. It doesn't matter as long as you pick one, right? Whichever way you want to solve this. In this particular case, I would say because they're already in y equals and y equals, then it's kind of an easy substitution problem, right? So I'm going to solve by substitution. So I'm going to say 3x plus 4, which is equal to y, is also equal to 5x minus 2. And then I kind of dissolve that. It's just a gateway. And then I can solve for my x. So I have 3x. What I'll do is I'll rearrange and I'll move my x's to one side and my non-x's to the other side. It doesn't matter which way you do it, but I'll do 3x minus 5x is negative 2 minus 4. If you don't like negatives, you probably would have moved things the other way, right? Because then you'd get a positive on both sides, but that's okay. As always, I like to kind of brute force things to show you that it still works. Negative 2 minus 4 is negative 6. I get x is negative 6 over negative 8. Is that true? Yeah. And is that anything nice? It's all right. you can leave it as a fraction. But I always check my fractions, because as long as it's not a repeating decimal, you can just use that, the decimal version. So now we've got our x. If I plug in x equals 0.75 in the first one and in the second one, they should give me the same value for y. Right? Especially, we'll start with the, now solve for y. Y is 3x plus 4. Then what I'll do is I will, this is optional, but I encourage you to do it. Do the other one as well. It's, you know, not too bad, 5x minus 2. But as long as you've done one to solve for y, it's okay. You'll see why. Y is 3 times 0.75 plus 4. Plus 4. I get a y of 6.25. And optionally, 5 times 0.75 minus 2. I did something weird. They should be the same. Where did I go wrong?
I already found my X.
Your x is 3.
I was like, I don't know if I.
You let me go this long? Maybe I didn't look up. I would have seen some skeptical faces. So where did I go wrong? 3x. Ah. Do I punish myself with red? I think I should. It's too far gone. I can't pretend I didn't make that mistake. Oh no. 3x minus 5x. Oh. And it is nice. And good thing I showed you that you should check your work. Because otherwise I would have just left it and you guys would have been probably confused. I hope. X is 3. Oh boy, I've got a lot of fixing to do here. Okay. 9 plus 4. Okay. Be cool, Emily. Be cool. 13. Does that sound right? Okay. And 15 minus 2. What a relief. And I get to go back to regular pen. No more punishing myself. But I only just barely caught that. Hopefully it makes sense with the red that I was bad. But now they're the same. Whew. So solve for x and y. I'll make it optional. Therefore, x is 3 and y is 13. Much nicer. Another word problem. Eek. A car rental company offers 2 plans. Plan 1 charges $10 a day and 10 cents a mile. While plan 2 charges 14 cents a mile, but no flat fee. Right, so you just start, and you pay per mileage. We'll start with A, of course. If you were to drive 300 miles in a day, which plan is better? Okay. But then B wants to know for what mileage are both rates equal? Now, same thing with a word problem. What's this word problem giving you? Right? It's giving you the equation of two lines, right? And they will intersect at some point. And so you can compare the two lines and you can find the intersection, right? So it's just that added step of finding the equations of the lines from the word problem. So for me, from this practice test, right, the question won't look like this, but it'll be, I give you two lines and you have to find the intersection of them and compare them, right? So it's the kind of core concept of the question, right? That'll be similar. Okay. Well, start with A. Plan 1 looks like what? It has, well, you can write it with the cost, or you can write it as y equals, if you write it as mx plus b, it's going to be the 10 cents per mile, right? That's your variable cost, right? And then your fixed cost is $10 per day. Huh? So here, this is your variable cost, and this is your fixed cost. Variable cost and your fixed cost happens to be 0 for the next one. Right? So you can write it as C equals the variable cost plus the fixed cost, or Y equals MX plus B is a little bit quicker. So we'll do that for the first one, 10X plus $10 a day. Boy, 10. That's a pricey drive. How about 0.1? 10 cents. $10 a mile. Yikes. That's some surge pricing. I'll clean this up. This was sloppy there. Whereas plan 2, oh, I guess we should evaluate at 300 miles. So here, if you drive 300 miles, then X is 300. You can solve these problems without lines, right? Without making them into a Y equals MX plus B form. Right? If you were just given this word problem, you could figure it out, right? 300 miles, 10 cents a mile, right? But really what you're doing is you're constructing this equation. So, all right. Y is 0.1 times 300 plus 10. 0.1 times 300 plus 10, I get 40. For plan 1. How about for plan 2? Y is 14x, nope, 14 cents. Wow, I really want to overcharge these car renters. And then you don't have to write the plus 0, but it might be nice. So Y is 0.14 times 300. I get 42. Well, if I'm choosing between paying 40 or 42, yeah.
If Oh, wait, I remember. If there's no flat fee, it automatically, or like if there's no fixed cost, it automatically is zero.
Yeah.
So unless it's given, it's not. Unless it's given it's zero.
In this case.
In this case, not all.
So previously, we had to solve for the fixed cost. Where did we have to do that? Here, right? So it depends on the information that you're given. Wow.
Since this one was 2 lines, so we didn't have to solve for it.
So, do you mean the one we just did?
Yeah.
Yeah, because this one, we have the fixed cost and the variable cost. We have the entire cost function for each plan. Does that
Okay.
make sense?
Yeah.
Question? Just stretching. You're allowed to stretch. But I'll think you're asking a question. Which one would I choose? I want to choose plan 1. Right? Plan 1 is slightly better. Therefore, to answer the question, which plan is better? Plan 1 is, well, cheaper, and usually that means better. But technically, it's only cheaper. What about B? For what mileage are both rates equal? Right? So what value of X yields the same cost? Right? So now we have to find the intersection. Solve for X at the intersection. And why not? We can solve for the cost as well, but it doesn't ask for it, so I can't demand it. We already have the lines, right? And so if I set them equal to each other, I can solve for X. And so I have 0.1 X plus 10, which is equal to Y, which is also equal to 0.14 X. And again, this one can kind of dissolve. Right? Y is equal to Y is the substitution that we're making. So let me not make the same mistake again. And I'll still, that's okay, it's temporary. 0.1 minus 0.14. I'll do it in light blue. You can skip this step if you want. 0.1x minus 0.14x is equal to negative 10. Then go back to must see negative 0.04x is negative 10. Divided by, I get x of 250. Is that sound good? Confirm the cost is the same. That x equals 250. Mostly because I had that blunder. And because we can. But it's all optional. 0.10 times 250 plus 10. So the cost is 35, or y equals 0.14x, which is 250. Phew. Therefore, at x equals, or 250 miles. This is optional. It didn't ask for this. That's why it's all light blue. The cost is $35. All it asked for was the X. Nice. Finally, an optimization problem. Let me just make sure before I delete this page here, because we're done with that now. Hopefully I don't need it again. Keep it on this page. So here we go. An optimization problem. You can just look at it and see, oh boy, a lot of work. A farmer has 100 acres of land on which she plans to grow wheat and corn. Each acre of wheat requires 4 hours of labor and $20 of capital, and each acre of corn requires 16 hours of labor and $40 of capital. The farmer has at most 800 hours of labor and $2,400 of capital available. If the profit from an acre of wheat is $80 and from an acre of corn is $100, how many acres of each crop should she plant to maximize her profit? Now, I give you this, and I'll give it to you on the test as well, and all your objective function and your constraints. So that's so nice of me. From the objective function, right, we're told to maximize the profit for 1 mark, which means half a mark. Usually if you mess one up, you don't get it. Right? But for 1 mark, X represents the wheat. The wheat, and you get 100 per acre of corn. So X represents the acres of wheat, and Y represents the acres of corn. Don't forget to do this one. It kind of blends in. Yeah.
If I just put wheat.
No, that's okay. But I want to see what you're measuring. I want to. But I also know that it's a test and it's stressful. So you can just say wheat and corn if you want. In this case. Okay. So let's see here. You don't have to lay out what the constraints are, but this is your total number of acres. Right? You can only, if you only own 100 acres, you really can't plant on more than 100 acres, right? You're kind of limited. And so here's your total acres. Here is your labor. And then your capital constraints. And of course, X and Y have to be greater than or equal to 0, which I kind of gave it away by only giving you the positive axes, right? And so there's no risk of going over. So these are already taken care of. Yeah. 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 It'll look exactly like this. So I'll have the question, give you the objective function, the constraints, and start off part A where this and this, X and Y, you have to tell me. And then part B, 7 marks, maximize the profit. This is where you have to know all the things that you need to do. So what do we need to do? Well, first we need to draw some lines, right? We'll start with, now, can I call this maybe line 1, line 2, and line 3? Just for simplicity. Totally optional. Line 1 is x plus y is, we'll start with equal to 100, right? To draw the lines, we set the inequalities to equal signs, and then we use the inequalities to figure out which side of the line we want. Okay. So to draw line 1, I need an x and I need a y coordinate. If I force, might be nice to let x be 0, y must be 100. And what if I force y to be 0, then x must be 100. That gives me nice anchor points. All right, so we'll draw that first. If x is 0, y is 100. And if x is 100, y is 0. Right? And you want to use a straight edge, but remember, you can just fold your, if you just kind of gently roll your page over, you can use that as your ruler, or the edge of your calculator like this. Well, you can't see it, I guess, but I'm doing it. It even got that little bump there. Here. Better. This is line 1. How about line 2? Oh, sorry, before I move on, what's another reason I did x is 0, y is 0, besides it being easy math, right? There are also potentially some intersections that I'm interested in later on, right? And so then it's nice to have them already, because then you don't have to redo that work. But line 2, 4x plus 16y is 800. How do you like to do it? Do you like to deal with the inequality right away, or do you like to draw the lines first? Maybe we should do the line and figure out which side it's on, do another line. That might be nice. But I think we did all the lines and then figured out the area, right, in class. I'm remembering now. Okay, we'll stick with that. Forget I said anything. Well, actually, don't forget that I said some stuff. How about we do the same thing again? If x is 0, then I get 4 times 0 is 16y, so y must be 800 divided by 16, which makes a nice 50. How about when y is 0? I get 4x must be 800, so 800 divided by 4, I get x is 200. Now you can pick any value of x or y or anything you want to solve for, but these are, I think, the easiest ones, right? 0, 0. So let's draw this line. When x is 0, y is 50. Oh, wow, 60, 40, 50, 60. How about there? And when x is 200, y is 0. So now, I gave you this rough grid on purpose, right? Because I want you to be able to see if the points you find are reasonable, but I don't necessarily want you to be able to look at them and tell what the intersections are. You have to solve for it. So this is line 2. Line 3, 20x plus 40y is 2400. I think, yeah. So if x is 0, 2400 divided by 40, then y must be 60. And if y is 0, I get 2400 divided by 20. So x is 120. So this line, x is 0, y is 60. And when x is 120, let's put it here. Not quite halfway. Roughly there. And guess I'll move my dot because I already drew it. There. And this is line 3. Okay. In terms of finding my feasible set, right, I've got a lot of options for my feasible set, but looking here, less than, right, and just kind of getting to know how inequalities work with lines, I know that it's going to be on this side of all the lines, right? So I suspect that a point in here will satisfy all the inequalities, right? So this is optional, right? Because what you could do is you could say, well, it has to be less than line 1, which means it's on this side of line 1. Has to be less than line 2, which means it's on this side of line 2. And it has to be less than line 3, right? And from there, all of those are satisfied, right? Starting at 0, 0. And until you move out. And this is your feasible set. So knowing that, you can use that. Or alternatively, use a test point. I've got maybe 2020 ish. 2020 to confirm the feasible set. Even look like a word. So in line 1, x plus y has to be less than or equal to 100. So 20 plus 20 is 40, which is less than or equal to 100. So that's satisfied. In line 2, now the reason this is in light blue is because you don't need to show me this work, right? I'm fine with you just understanding how inequalities work, and as long as you shade the feasible set, I'm happy. So this is all optional. Line 2 was 4 times 20 plus 16 times 20 is 80 plus 16 times 20. It's 400, which is less than or equal to 800. And line 3, 20 times 20 plus 40 times 20. 20 times 20 plus I get 1200, which is still less than 2400. Good. So it is in the feasible set, which means it'll be the only region that satisfies all the constraints. Okay, then starting at 0, 0, right, that's a vertex. I'm going to label it A, B, C, D, and E. Let's move this over. Our next job is to find the vertices. Need a page though. Vertex A is at 0, 0. That's always an easy one. B, we already found it. So I'm going to show you that you don't have to do any work because we already did the work here. Is the intersection of what? Of x equals 0, right? And line 2. Is it line 2? Okay. You're allowed to just say 0, 50 from earlier. So if you're not showing any work, then you have to tell me that you did it earlier. C, we're going to have to do some work. It's the intersection of line 3 and line 2. I'll do L2 and L3 just for simplicity. Line 2, let me see how much. I don't have that much time. These are so long. Line 2 is 4x plus 16y. Is 800. And line 3 is 20x plus 40y. 400. You can use whatever method you'd like, but in this case, you can use substitution or you can use elimination. This one is kind of ripe for elimination, right? All you would need to do is multiply line 2 by 5, right? And then you'd have 20x and then minus line 3, right? Should we try it? Yeah.
Could you do the other way though, like do the 20x, but like the line 3 divided by 5?
Oh yeah, I guess they all divide nicely by 5. Yep, you could do that. Either way, yeah. Yeah, lots of options. Yes, you can. And usually that's my go-to, right, is the substitution method. But in this case, let's stretch our elimination method. I'm gonna go by 5 times 4x plus 16y is 800. And then I'm going to subtract 20x plus 40y. It's 2400. See what's left. Doesn't really, it's not quite ready yet. Sorry. I get 20x, that was the goal. Plus, what's 5 times 16? Who knows? 80y. Uh-oh, 800 times 5. It's huge. Well, 4,000. If I subtract then line 3, you get 0x, that was the goal. Plus 80 minus 40 is 40y. And 4,000 minus 2,400, so I don't slip up, which means that y is 1,600 divided by 40, which makes a nice 40, which hopefully looks reasonable. It does. Phew. So then, using either of the two lines at y equals 40, four x plus 16y is 800. Oops, I'm going to replace this y with 40. 16 times 40. I get 4x is 800 minus 640, which is 160. So x also 40. And just want to make sure that that looks reasonable. It does. Oh, and I should say here, link those up. Sorry, kind of floating around. So then C is at 40, 40. D luckily we've already done the work for E. D is the intersection of line 1 and line 3. Line 1 was x plus y is 100. And line 3 was this 20x plus 40y equals 2,400. Now in this case, because I have an x or a y, both of these are easy to solve for. You can use substitution. You can use elimination again if you want to. You should find the same thing though. So here we get y is 100 minus x. So then 20x plus 40 times 100 minus x is 2,400. Expand and solve. 20x plus 40 times 100 is 4,000 minus 40x. 20 minus 40 is minus 20x, and 2,400 minus 4,000, negative 1,600. Divided by 20, I get 80. Go back and check. Does that make sense? Looks good. X equals 80. Okay, I'm sold. If y is 100 minus x, and x is 80. I get y must be 20, which hopefully also looks good. It does. It looks like I'm a little bit off with my lines, but that's okay. So then D is at 80, 20, and E is at 100, 0 from earlier. I know I'm almost out of time. I'll keep going, but I understand if you have to go because buses and things. Don't worry. But then it's in the recording. Okay, what's the next step? So now we've got all our vertices. So much work. Yeah,
I have to do the vertex.
totally. I like to make a little table where I outline what the vertex is. And this is the first time that we dust off the objective function, right? The profit. Because our whole goal was to maximize the profit. Profit is 80x plus 100y. So at each vertex, and I like to label them A, B, C, D, E, have E here, 100, 0. Start there. D was at 80, 20. C was at 40, 40, and then 0, 50. At vertex A, profit of 0 satisfies all the constraints, but you're probably never going to choose that one. So then we move on to 80 times 0 plus 100 times 50. I get 5,000. Right? 80 times 40 plus 100 times 40. Slightly better. 7,200. Let's keep going. 80 times 80 plus 100 times 20. 80 times 80 plus 100 times 20. Woo, I like that one. 8,400. Or 80 times 100 plus 100 times 0. $8,000. Therefore, the profit is maximized to $8,400 when X is 80 and Y is 20. Wheat and corn, blah, blah, blah. Do you want me to keep going here or do you want me to finish the recording? So I will finish the practice test regardless. So whether you want to stay here or I just walk it over to my office and I do it there, it doesn't matter to me. You're welcome to stay. I'll just keep going here. But I know we're out of time, so don't worry about it. So, but I do want to have it all in the recording. Okay? So it'll be in the recording, I promise. but we'll keep going. I'll do this one, yeah.
What if I question about like why?
How about I pause the recording? So that we, yeah, if anyone has any questions, but I'm just gonna pause this here. Or maybe I'll start a fresh one. How about that? Cause it's, everyone's gotta. I'm gonna stop this.